So let me introduce our speaker. We have Abhay Agarwal talking to us today. He is the founder of Polytopal. His background is basically that he has worked at Stanford, working on basically design of AI systems for humans, with an emphasis on the design aspect. And in the core, he's worked with a bunch of different, I want to say companies, but maybe other institutes as well, other organizations as well, on like helping, consulting with them to help them design AI systems, and has learned a bunch of lessons from all of those interactions. And as a result has developed a design language for AI called Lingua Franca that I believe he will be telling us about today. And so yeah, Abhay, take it away.
Cool, thank you. Thank you for the introduction. That's very kind, and also very kind of you to allow me to speak to your community in this interesting time. So thank you all as well for attending. So this talk is called Intelligence is Overrated. So it's a little bit of an obviously provocational title, but I hope it'll create a lively, healthy debate and conversation amongst all of us. And I'm very super curious to also hear from you all at the end of the talk. I'm going to leave a lot of time for discussion and questions, as I am super excited to be introduced to this community. So let me just quickly reintroduce myself a little bit. So I founded a company called Polytopal, but before that I was a lecturer at the Stanford Design School, where I created a course called Designing Machine Learning. I'll talk a little bit more about that. And I'm a member of the Stanford Human-Centered AI Institute. So I'm now having the pleasure of interfacing with both Hi and Chai, so that's fun. But prior to that, I was an AI research fellow at Microsoft Research, where I focused on reinforcement learning and computer vision. I have a master's in design from Stanford and a bachelor's from UC Berkeley. So hopefully I'm sort of following in the Stuart Russell footsteps of interfacing with both institutions on either side of the bay. So about Polytopal, we're in what I would call an AI design firm. It's sort of a new concept, but we really take stride in this notion of human-centered AI, and we try to build human-centered AI in practice for global companies and brands. We've worked with companies like Spotify and JP Morgan, and we're just starting a relationship with Nestle. We work in spaces across ethics and domains such as fairness and bias, and we also do what I would call traditional product design, so usability, user interface, user experience, but in the context of these very meaty and challenging systems, AI systems. So I'll talk about that a little bit later, but actually I wanted to, before I move on to the next slide, I just wanted to orient the conversation around what this talk will be about. As Rowan mentioned, we have developed a design language, but I actually wanted to speak more to what I feel like might be relevant to this community and talk about, maybe at a high level, where AI as a field is going. So I'll definitely try to make it relevant to you all and not toot my own horn too much. But to toot my own horn a little bit, so we created this course, Designing Machine Learning, at the Stanford Hasso-Plattner Institute of Design. It was a course intended to create an interdisciplinary collaboration between different professionals of different groups. And so our first class was comprised of folks across business, healthcare, law, engineering, and a variety of other fields. It was co-taught by myself and two other folks, Michelle Carney, who was at Google People in AI Research, which is another 3 or 4 letter acronym that all of you should look at, and then co-taught as well with Anand Rajaraman, who's a VC serial entrepreneur and was actually the inventor of Amazon Mechanical Turk. So really interesting voice for that conversation. If you're interested in that course and kind of what it means to teach design and AI together, all the course materials are available at that link, https://designwith.ml. So I'd really encourage you guys to check it out if you're interested in what curriculum kind of looks like in this space. So again, my goals in this talk are fairly high level. I really want to actually take stock of the AI field and really help us reassess what does it mean to be building intelligence, and is that actually the goal? I also want to, in the process of doing that, surprisingly kind of introduce a new stance in the debate on AI ethics as well. So this conversation will sort of have broad-reaching tentacles, and some of those will touch on AI ethics and algorithmic fairness. I also hope that this defines a new direction for human-aligned AI systems, which I know is something that you all have thought very deeply about on both practical and philosophical grounds, and then obviously leave enough time for lots of questions. So I hope that even if you don't agree with me or that you see value in the conversation, that at least it'll introduce a new viewpoint that you might not be as familiar with, from whatever context and research background that you come from. And I'll just quickly sort of provide my thesis through the talk. And what I'm trying to say is that intelligence, how we approach it in the AI field, and I'll actually define what I feel like that approach is a limited measure of capability, empowerment, or value. And when I think of that, I mean capability, empowerment, and value potentially to AI agents, if we embody the AI, but also thinking of AI as a system that's providing value to society. And I also think that it can actually be counterproductive to progress. So instead, creating systems that are more effective at interaction, in my mind, will make AI research and the world a better place. So let's start with some terms. Obviously, we need to kind of be rigorous about what we mean by intelligence and interaction. So in the field of intelligence and AI, I think that these days the gold standard of intelligence is, of course, this sort of idea of out-of-domain generalization, OOD. But unfortunately, for the use of out-of-domain generalization in any practical respects, it's fairly limited. We don't actually know when out-of-domain generalization, the standard, has been met. We can obviously define various contrivances to meet that, setting up various out-of-domain data sets, but inevitably the interpretation is actually fairly subjective. So if we want to think about comparing intelligence to other metrics of success, we probably can't use out-of-domain generalization that fruitfully. Ironically, out-of-domain generalization is unfortunately domain-specific, what it means. For example, if I teach an AI to drive on city streets, what does it mean for that AI to have out-of-domain generalization? Does that mean that it can now drive on streets that it's never seen before? Or does that mean that it should now be able to generalize to both driving and flying? Or potentially does that mean that I should be able to limit the machine in some way, for example, remove a wheel and have it recuperate from that issue or break a sensor? We don't actually quite know, and our metrics of success are fairly limited. So for the purpose of this talk, I'm going to choose a much easier kind of framework of success for an intelligent system, and hopefully this is something that most of you can at least sympathize or see some sort of immediate value in. Just a simple matrix completion framework. Just imagine you have an Excel spreadsheet and you're trying to replace values or fill in blank spaces on that spreadsheet. Fairly general purpose, and I think many of us might be able to at least afford it some leeway to say that a system is intelligent if it can do this. You can obviously enforce some constraints on the data set and the domain to say maybe it's IID and therefore it's not this out of domain, but it could also be out of domain under various interpretations. It also includes this kind of X to Y mapping. Obviously, just assume that the Y values are the ones that don't exist, or it can generalize to missing sensors or augmenting the data set itself, et cetera. So it's a fairly general purpose framework, and I think I'm going to show you in this talk how various approaches and formulations that use this kind of measure of intelligence tend to be fairly limited and not in like a gotcha way that there's some mathematical formalism that this doesn't provably meet, just in very common sense grounds, how this can be a very limited sense of intelligence, even as it approaches or applies to the real world. Given that, now I have to sort of define interaction. So interaction is really, think about this kind of like time series state formulation of the world. We have some observation of state, perception function that at a specific time is able to observe a state. We would have a desired state and a value function that maps to that desired state. So this is what you guys might call the human alignment problem at CHAI, is that how do you define a value function to go from an observed state to a desired state at all? But let's assume that you can approach that with any number of different techniques, for example, the matrix completion framework that I gave prior. However, in order to have interaction, you really have to have some capability of taking that action. So this mapping of an I function And then you have these sort of theta parameters, which are the degrees of freedom of this artificial intelligence system. So then you say, okay, well, what does that mean for a system to interact? What am I solving for? Some people might say, okay, well, maybe by interaction, I'm actually solving for these parameters to find the degrees of freedom that map to this desired state. And most of AI research seems to assume that to be the case. However, in the case that I'm talking about, that's actually not what I'm describing. I'm actually describing how do you define I as a function at all? And just keep in mind that I as a function is how do I imagine my system interfacing with the world, right? And so if you think about different ways to interface with the world, it's actually a design spectrum, right, that you might call it. You can grasp and use dexterous manipulation, or you can interact through a system or a human agent. So you can be a decision support system that gets to the desired stuff, for example, a successful surgery. And if you think of something like a video game controller, it's the perfect embodiment of that interaction design as reducing the degrees of freedom, but increasing the sort of state of happiness at the on the other side of the system. I'm actually reducing many different problems to a single vehicle in which I interact, right? Because it would be very annoying and challenging if for every game that I played, I was learning a completely new interface, right? So the theta is not actually what I'm talking about here. It's the actual interface itself and what I imagine to be the embodiment of that. And that's really what we actually develop, though in a sort of unthanked way as part of our research. So now that I feel like I've sort of defined the terms in sort of a moderate way, let's kind of motivate the problem with what I would call a pithy thought experiment. So what if you had a jellyfish and you gave it a human brain, right? What if I gave a jellyfish a power of extreme intelligence? What would actually happen to the world, right? Would you assume that, that this becomes a runaway intelligence that takes over the seas and gains the nuclear codes and then dooms the human race for the rest of time? The answer is probably no. And the reason for that is because the jellyfish is probably fairly unable to even perceive a meaningful slice of the world beyond a few feet around it, right? Its capabilities of interaction are extremely limited. It has several tentacles and it has some chemical receptors. It actually doesn't have the capability of having a confidence of its perception of the world beyond a few feet away because its chemical receptors are not able to capture that, and then therefore noise would encompass its zone of reality around it. It literally can't see above water and therefore cannot perceive a human life. And I personally cannot imagine a situation where even a hyper-intelligent jellyfish capable of inference is able to sort of do more than sort of this fairly defined, limited set of capabilities. So this is what I actually call the superhuman jellyfish paradox. And to me, this motivates this larger question of, okay, what does it mean for us to develop an intelligent system in a vacuum in which intelligence is defined as a capability of inference? Well, it's probably more than a capability of inference after all. It probably requires us to at least give some value to how it interfaces with the world around it. So kind of moving to a more tangible space, I'm going to actually introduce 3 what I would call open problems within AI that I think interaction can actually develop a very strong sense of alignment and give a direction for research. So the first one being AI ethics and algorithmic fairness, and then human alignment, which is not the human alignment that you talk about, but more of a sort of temporaneous, short-term human alignment, and then this notion of synthetic environments and synthetic data to train AI models. So in the AI ethics world, some of you might not be familiar with this notion of algorithmic fairness. Some of you might be very familiar, and it might be your entire research career. Again, I mean no sort of harm or offense to people for whom this is their primary area of concern, but I do want to bring up some very significant issues with that, especially as it's formulated right now. So in the algorithmic fairness world, really what they're trying to do is they take a set of data and essentially they formulate it as an intelligence problem. They reweight the model, so they change the loss function, and they have some unknown value in the table, and they try to predict that value to meet an additional domain constraint being quote unquote fairness. So they have to then create a notion of fairness. In this case, we can say group fairness, which is a widely known and used fairness metric, where users from a given sensitive class, in this case ethnicity, should not have lower scores on average than other classes. So it's an additional domain that changes your loss function that then allows you to train a new model that does that prediction. So again, as we mentioned earlier, this is very much under this domain of what matrix completion style of intelligence means, right? There's a question mark, you have to fill that in. But what's actually happening underneath the hood in this system that makes it so challenging and potentially fraught as we try to solve it? Well, one is there's this notion of the transference of the bias. So the bias prior to the use of an algorithmic fairness method was pervasive through the data set, through the data collection. However, when you reweight the model to protect these given sensitive classes, you actually transfer a lot of the bias and sort of the weighting to this ethnicity. So now the degree of error and the degree of messiness of your data is now heavily reliant on this ethnicity class. Now, ethnicity is not something that is set in stone. Ethnicity is also an opinion and relies on the way that you collect the data. It relies on a subjective interpretation of what someone's race is. So when you use that as the anchoring sensitive to define, for example, a score, you're transferring a lot of the bias under the hood back to the data collection process. But more challenging than that is you open your data set to a much wider variety of adversarial attacks, because there could be this notion of affirmative action hijacking where people recognize that your ethnicity is a highly predictive class, and because they know that you've reweighted it for socioeconomic reasons, et cetera, that your score, given I'm a white person with the rest of my data points being according to my socioeconomic status, changing my ethnicity to Native American might vastly increase my score, and I might be able to predict that in a very interpretable way. And then finally, it brings up this question of whether we're actually able to eradicate bias simply by defining sensitive classes at all. Maybe we have a whole range of proxy classes which together are both sensitive but also predictive. And I don't mean this to say that there aren't solutions to these questions. I mean, there obviously can and perhaps are, depending on different formulations. But it should cause you some questioning to at least say, is a purely intelligence-based formulation of this problem actually the right approach? Like, are we willing to deal with all of these additional issues in algorithmic fairness if the problem is actually stemming from the fact that we've assumed that it's an intelligence problem rather than whether it lies outside of the domain of intelligence? In my mind, and I don't have any data to back this up right now, I will obviously show examples in which I do have data to back it up, but from the algorithmic fairness world, I firmly believe that we can actually address this problem with better interaction design of our interfaces themselves that overcome these issues through deep and meaningful research into the procedural bias, so the revealed experienced bias that exists in any given system. And that means rethinking what the interaction design formulation is for this interface, right? Is it a decision support system? Is it an automated system? Is it a triaging system? And then understand how those have sort of bubbling repercussions to the rest of the system that it affects, and then evaluating it on this kind of longer term feedback loop. If you want a peer-reviewed piece of research for this, and you don't want to take my word for it, there's a link, and I'll share the slides to folks if they want afterward, but it's a really great reading on some of the issues within algorithmic fairness. I'll go through two more examples quickly, and then an example in which I feel like we successfully utilized interaction design to inform a product, and then quickly describe lingua franca and open it up to questions from the group. Also, feel free to interrupt if you want, or ask questions in the chat. I can bring the chat up so that I have a view of it. So this next issue is around human alignment. Now, I'm not talking about in this case human alignment as this hard problem of human alignment, the sort of problem of aligning AI with the long-term human and social values where we're trying to make it better for the world around us and understand what that means. That's not the human alignment I'm talking about. The human alignment that I'm talking about is a very soft human problem of, can we actually build a system that is useful to a given person at a given time in a given context? That's really what I mean by human alignment. So that extends to products such as making the right recommendation of music to someone on Spotify, or giving a product recommendation on Amazon, right? Can you make an AI that's human aligned and recommends or delivers value to that person? So the example that I can use to describe this is actually the Netflix prize. So some of you might be familiar with the Netflix prize. but it was in the early 2000s, Netflix created a challenge which would award over $1 million to teams that were able to improve upon Netflix's own movie rating prediction algorithm. So they released a public data set of movies and ratings, and they asked the public, can you solve this problem for us and create a better algorithm? Now, interestingly enough, Netflix never actually used the winning algorithm. So someone created a winning algorithm, they awarded all the money, and years later, they're not using it. They never used it. So you have to ask the question, why didn't they end up using it? Well, the answer is actually quite straightforward, is that the algorithm was not actually useful. So the system actually that was designed, the algorithm did a great job of predicting the user's likeliness to review a movie favorably using sort of fancy matrix factorization. The system, it turns out, in a way, actually did predict what people would like and when they would like it. It just did too good of a job at it. So the system, it turns out, was actually predicting movies that a user would like and that they did like, but that the user had likely already watched. So it was movies that they had already watched, maybe they forgot to rate them on Netflix, or they'd watched them in theaters or in another medium. So it turns out that when this system, if you think of like the sort of the asymptotic value of intelligence in the case of the Netflix recommendation system, is it actually goes negative, because you then suddenly, it turns out, you're simply recommending movies that someone has already seen, and therefore you're only accounting for missing values in the data set. Again, this notion of intelligence that's very relevant and important, but might not actually be useful in this particular context. So it never actually made Netflix any money. So that's one of the reasons why they didn't use it, and there's a really fun Wired article about why they didn't use it. But kind of more to the point of how interaction might solve this is Netflix actually, at the same time as they're introducing those algorithms, were also introducing streaming. So it turns out that their business challenge, what they wanted for users to do, had nothing to do with the intelligence of predicting a movie rating and had everything to do with keeping people on the platform and having them watch more movies. And yet, if I were to continue to reformulate this problem as an intelligence problem where I'm now predicting, a variable that is someone's amount of time that they're likely to spend on the platform and et cetera, then you're creating an even more challenging system with even more degrees of freedom, with more training, et cetera. Instead, in my mind, the solution really is to formulate the intelligence, formulate the interaction of the user with the system to maximize value without pulling everything into this domain of intelligence. And then lastly, I'll give this example of synthetic data and environments, and you probably know where I'm going with this, but synthetic data and this problem of gathering data synthetically to train models is really, again, pulling this notion of data collection into the domain of intelligence to say that, okay, well, we have these missing rows in my data set. What if I were to use intelligence to actually predict those rows and then develop a system that gives me synthetic data? So a lot of systems are doing this, and I would say it's fairly limited. It's very challenging to get it to work. I have a ton of experience with this system. I was on the team at Microsoft that developed AirSim, which is probably the most widely used synthetic data platform for training vehicles and quadcopters specifically. It was really challenging. So, I mean, take a look at this video of Facebook's Habitat Sim, which is a habitat simulator tool released by Facebook. Does anyone notice anything weird about Habitat Sim? Is anything missing from all these videos?
I mean, there aren't any people, which seems a bit odd.
There are no people. There are no people. Exactly. So the one key source of uncertainty in your system when you're interacting in home environments is human beings. And yet those cannot be modeled effectively within this habitat simulator. The reason being that humans are leveraging uncertainty, and they leverage the interface that they're working towards. If it's a flying camera, it's a very different human interaction problem than if it's a camera on wheels, or if it's just a camera sitting inside of the wall peeping on somebody, right? There are different interaction modalities, and that absolutely fundamentally changes how the data would look and how it would be collected, except in these kind of contrived instances where you're in a fully lit scenario with no objects lying around, where you have complete control of your setting. And so in some ways, to me, this synthetic data problem is really a manifestation of what I would call an overall bias with these systems that try to pull various problems into this framing of matrix completion, when in fact there's probably a broader question about how to interact with these systems and not sort of an a priori intelligence. So again, these are 3 open problems, and I haven't been able to give them a lot of time, and I'm happy to engage with you guys more sort of deeply through the rest of the talk to try to like tease out why these are really challenging and how interaction design, as I see it, is really a solution. But I just wanted to outline that they are what I would call open problems, and I do think that part of the issue with why they're not solved or addressed in a meaningful way is that we continue to try to formulate them as pure intelligence matrix completion problems. So before I move on to my sort of example that's supposed to impress you, is let's try to address very head-on some common counterpoints to this argument and why this is not a common argument that you'll hear, you know, across conferences like NeurIPS. So a lot of people would actually say, well, I actually already work on interaction. This doesn't speak to me at all because I work in reinforcement learning or controls or HCI. HCI has the word interaction in the name, so why are you saying that I don't work on interaction? Well, the idea behind modern HCI interaction is really, actually they're trying to pull interaction formulations and pull them into the intelligence version viewpoint of the world. They're trying to say, I have this interface with tons of different buttons and UI elements. Can I use intelligence to rearrange and dynamically adjust the interface or dynamically design a robotic manipulation tool so that it meets the problem without sort of thinking of the interaction as a separate challenge? We're trying to bring that in and sort of entangle it with the intelligence system so that I can train a model and a loss on the interaction itself. Now, I'm not saying all of you do this, but it's a fairly pervasive trend and what I would consider a worldview of HCI and reinforcement learning folks, right? Like, so that's one argument. The other one is that people think that, well, intelligence really has to be a prerequisite to, or is a necessary or fundamental piece of, or supersedes interaction. And to that, I would say that's something that I would disagree with. And I think if you just take a naturalistic approach to the world, intelligent beings like humans had limbs and organs before we had massive oversized brains. And so in some way, we might even think of the interaction modalities of a human as being a prerequisite to our intelligence, is that we didn't need intelligence until we actually had the capability of dexterous manipulation, of opposable thumbs, et cetera, in order to actually create the context for which intelligence can help us navigate this massive kind of hyper-dynamic degree of freedom of what to do. Thirdly, people would say, well, my work doesn't distinguish. I am part of this new trend. I work on unification or free energy minimization, or I look at curiosity, surprise, and intrinsic motivation, which is, you know, the combination of interaction and intelligence. But I would also say that this is the typical case of like fixating on a particular interaction and then trying to bring intelligence into that interaction without modifying or manipulating what that interaction would look like. And so you kind of think of this as a combined problem when in fact, you know, it really might make sense to say, what's the best tool to actually allow intelligence to be limited and in scope, but expanded in capability. And that's something I'm happy to expand on more if that doesn't feel like a satisfactory argument. And so that also addresses this idea that is very widely pervasive, is that we should just standardize all of our interfaces, give everyone the standard PR2, give everyone the standard KUKA ARM, and then see who can do the best job, like who can make it do the coolest things. But to that, I would probably say that these standardized interfaces are not actually exploring the realm of possibility of what intelligence can do, because you're not enabling it by letting it meet some of the constraints of the problem. You're hindering the system artificially in order to make it sort of more sort of focused on intelligence.
Can I ask a question about?
Yeah, please.
On the first bullet here where you say I already work on interaction, I don't think I fully understood your what counter argument you were propping up with that bullet. And I don't think I really understood your reply to that argument. Would you be willing to just try to maybe explain again what you were trying to convey with that first bullet?
Yeah, totally. And again, I don't mean this to in any way, disparage folks who are working in these spaces. If you're an HCI researcher, I'm obviously I have more in common with you than not. So I don't want you to take this as like a shots fired here. But what I'm trying to say is that in the HCI domain, as I see it, in the last 2-3 years of HCI research, especially as it pertains to artificial intelligence, I think there's a trend of thinking of HCI as something where the interface should be derived by an intelligent system. So for example, in an education system, that the intelligence should be able to manipulate the interface and the tool to sort of match the user the best, instead of thinking of the interaction as its own value system where I should create the best interaction design possible and let intelligence flow through that. Instead, we're saying, well, let's be as tabula rasa as we can on the interface, maybe define a library of interaction techniques, and then let the intelligent system pick between all of them and define how it interacts with somebody. Again, this changes based on different domains. I mean, if you want to give a particular example of an HCI system and you want me to just give an interpretation of whether I feel like it is good or it's not good, or it is fraught or not fraught, I'm happy to do so.
Yeah, could I try maybe restating one of the points you just made? You can tell me if I'm like understanding. When you're saying, you were saying the traditional HCI approach in this education example would be to think about like the intelligence has some actions it can take, which would be manipulating the interface that this education system might be showing to the user. Is it fair to characterize what you're saying as like we should think of the system kind of like just broadening or like enlarging the scope of what the system here is, and like how we should be like evaluating what we're designing, where like
exactly.
the kind of HCI thing would be, okay, the system is just what pixels do I show, like basically the scope of the system is like what pixels am I showing on the screen at any given time, whereas you're saying like there should be this broader system design question that includes the interact, like I'm not, I don't know
yeah, totally.
how you would say
we should
broadening what the system is.
Yeah, so I think the easiest kind of litmus test is, should such feature be intelligent or should we design it intentionally, right? So for example, think of a school environment. Obviously it can be sort of contrived, but conceptually, we do have intelligent agents that teach students. We have a teacher. However, that teacher exists within a context, for example, standard textbooks, an environment such as a chalkboard, and other materials and resources which are absolutely not dynamic. They're fixed. They're fixed because they provide a special value to the overall expression of intelligence. And so this trend, which I see happening before me, is we think of interaction as something that the AI engineers should actually design without this, kind of human-centered or design problem-oriented approach to seeing what can solve the problem. They think, how can we get an AI to know what the problem is and solve it and redesign the system all at the same time? So create these sort of like Uber models. Okay. So just to, again, and the reason I use the education example was so it would segue into this product that we helped build. If you think about creating an education system, an education platform purely in intelligence, which I think many people do hope to do that or think about it that way, you would have so many degrees of freedom in that education system. You'd have to perceive what a student is telling you. You would have to dynamically adjust what content to convey to that student. You'd have to assess that student's learning in real time and also then adjust the entire context of that education. So it turns out that that formulation is just incredibly challenging, takes tons of time to do, would be incredibly infeasible to implement, and there's many gotchas along that process. So instead, we can take a more constrained formulation and just think of what is the best interface to actually express a limited knowledge system, a limited intelligence system, and have those two systems work together so that the intelligence is actually not deciding what to show. It's just an interactive display of various kind of intelligent features that lets the student kind of parse and explore that on their own, alongside, a structured piece of material like a textbook, right? So the textbook is fixed and intentional. The AI is not dynamically generating text. The AI is not, dynamically showing what content the student should learn, but it's providing an augmentation to that underlying material in the form of automated study questions, of automated diagram generations, and other kind of techniques that, in my opinion, are more harmonious with the overall context of the student's education. And again, this might be a contrived example because you might think of this as like the obvious solution, whereas the AI engineers who are doing, an end-to-end model are solving the hard problem. But in my mind, there's actually more benefit to allow these constraints to define your AI than the other way around. So before we move on to kind of questions and discussion, of which I hope that there's tons, and I hope that this resonated and landed, at least in some way, with some folks, I just want to mention that here at Polytopal, we've made many inroads, I believe, into actually thinking about what interaction design for AI looks like in a rigorous, methodical way. So we published a large book called Lingua Franca, which is a guide to the interaction design of AI systems that has developed a handbook of how do you actually develop interaction design in tandem with AI, like how do you unpack and parse the constraints of artificial intelligence while also leaving room for intentional design. We've also created a variety of principles that are ways for people to sort of align themselves towards a goal within their system that they're developing, rather than having the sort of AI be the system defining the goal as well. What are some general concerns when implementing AI systems that interface with people and general social structures? And then we've also developed a library of 20 kind of quick start tools. So like kind of if you're developing an interactive sort of an interaction design for an AI system, what are some of the pieces that I can think of using, right? A lot of people would say, I don't know. I was hoping that the AI would just take a bag of tools and just jumble them together and eventually become smart, right? That's the hope, is that I don't have to start a priori with some of these kind of thoughtful or intentional kind of design choices. So we've developed these what we call elements to help solve that problem for people. So great. So that's my talk. I haven't talked much at all about what we mean by human-centered AI, but Lingua Franca as a document goes over it extensively, defines it, gives all sorts of examples and case studies as well. So I'm happy to talk more about it or take questions or just hear what you guys have to say. And maybe I didn't hit the mark at all and this entire conversation feels like it wasn't in the right direction for you. I'd love to hear your feedback.
All right. Yeah, thanks, Abhay.
The claps all get muted, so it's
yeah.
I understand.
Yeah.
But
assume that everyone else. I'm clapping on behalf of everyone, but unfortunately, I can't clap that loud.
Thank you.
But yeah. So yeah, let's open up the floor to questions.
Let me just share the right here. So I can just quickly go to whatever slide.
Yep, sounds good. Okay, I guess I'll start with the question. So as I understand it, like a main thesis of yours is that we shouldn't be handing off interaction to the agent right now or to the intelligence.
Yeah, the inference building system. Yeah.
Yeah. Which I think I definitely buy that right now for most applications, but I'm curious what you think about, like, do you expect this to be the case forever? Do you expect at some point it would make sense to delegate the interaction to the intelligence system? Are we talking like this will never happen? This will happen in a century. This will happen. This will happen in a decade. This will happen in a year.
Yeah, so in my mind, I would say it's not one of can we do it? It's more of one of are we building best fit system for the job? So I think we all need to at least recognize and appreciate that in this kind of global race towards building AI, that the AI that completes things the best and accomplishes more will win, regardless of whether that AI is at its purest, the more elegant approach, right, in which everything is subject to the same inference building, and everything is a model where you're back propagating, a single loss through the system, and that can encompass multiple modalities, et cetera. I would say that for the most part, I would argue that it'll never be the case where that end-to-end system is going to outperform unquestionably a system where parts of it have been tailored and tuned to successfully match a certain function. So for example, thinking about it, like is a pizza making robotic hand going to be better than a pizza making machine that squirts out the pizza dough and lays all the toppings on it? Will the hand ever completely subsume the machine? So one is where the hand has all these degrees of freedom and it can learn, and then the pizza making machine is just like been tailored to do it, and maybe there's some intelligence in like when it's done or whatever. The pizza making machine, for all intents and purposes, will for almost the rest of humanity make pizzas faster than the robotic arm. So in my mind, if we kind of understand these constraints that we're in, then I think we really have to rethink whether we are approaching this as an intellectual exercise or whether we're trying to build successful AI systems.
Yeah, that makes sense. I guess I'm curious. I think like one question I often ask is like, any argument that we make about AI systems, can we also make it about humans? I'm curious what you would think about that. Like,
totally.
To what extent do your arguments also apply to humans? There is sort of a difference in that we can't really change how humans are embodied, but maybe
right.
Maybe
so I think the analogy here is that when a human has to go do a job, does our body sort of like grow a new limb designed for that job? Or do we have a very capable body that's fairly general purpose, but also fairly constrained in its abilities? And then do we solve it with that? So is our intelligence actually more powerful because we've built it within these fairly interesting constraints of a very capable body, right? We're not intentionally hamstringing our intelligence. I think we're actually empowering it by giving it such a great system to deal with. So we're not saying put a human brain inside of a box with like two levers and see whether that box with two levers can beat a human at chess or something, right? We're saying, are you going to be able to accomplish meaningful change in the world? And to that, I would say, naturalistically, I feel like interaction. I feel like my thesis is supported by the naturalistic argument.
So I'm a bit confused by that. It feels like that pushes the other way.
Well, if you think about it as a time boundary, so did our intelligence precede our limbs, or did our intelligence precede our ability to do sort of what I would call low-level activities? And the answer is no. Our limbs were much more capable and built before we had extreme powers of intelligence to sort of overcome these limitations.
But I guess what that feels like it argues to me is that it argues for like a two-phase process, where first phase we come up with a interface for like interacting with problems, which is general enough to be able to do anything that we could possibly want. And then phase two is we just scale up intelligence within that interface. And it seems,
so I mean, sorry, go ahead. Finish your sentence.
Yeah, it seems like people who are following like a more standard AI approach are thinking of the systems that they have as like approximating like the general thing for solving the tasks that they're trying to solve. In which case, it feels like they are following the paradigm that you're outlining.
So again, I would say that the naturalistic argument is really more about our cognition and our capabilities. But if you explore the world around us and the systems that exist outside of us, we don't solve every problem with humans. We have we build machines that are capable of solving those. And the reason is because our brains and our ability to be intelligent about these systems is limited to certain domains. And so we know specifically that our our intelligence is not the key necessarily to unlocking. We still need capabilities. Now, you can say, okay, well, the humans are the ones enacting those capabilities. The humans are the one building things, blah, blah, blah. It's this root source of all intelligence. But in my mind, that feels like you're basically forcing the AI industry to start from these first principles that it doesn't need to start from. And the question is, are we going to build the best intelligent systems by mimicking sort of the rise of an AI organically starting with a limited agent that has to then build its way out of its own struggles? Or is the most powerful AI system going to be one that's cognizant of its capabilities and uses sort of interaction modalities that are fit for the problems that it wants to accomplish? And I think along that trajectory, we might find a variety of general purpose systems, but I don't think we're nearly there to really say that we found great general purpose interaction design for intelligent systems. It's not going to look like a human hand. It's probably going to look very different.
Okay, so then most of the argument, so I guess it feels like there's two parts to the argument. One is that when designing an AI system, you design two parts. One is the interface, and the other is like the learning algorithm. And really, a system that is best for a job in any like particular time in history is going to be doing pretty well on both of these axes. It's going to have like a pretty good interface that is like particularly well suited for solving the sorts of tasks that are like we were wanting to try to solve, and also for being able to be easily learned by the sorts of intelligences that we have around at that time.
Yeah, exactly.
And it feels like the other part of that argument is that that if there are interfaces which are fairly general and able to like be really good interfaces for a lot of tasks, then we just aren't there yet in terms of what those interfaces are, or at least we're not there, or like a combination of either we aren't there yet in terms of the interfaces that we have available, or we aren't there yet in terms of the AI being able to use those interfaces broadly. And that, I guess, there's an extra argument of like we're not going to get there soon.
Yeah, so I think the key part that I would say that you're missing, I think that's a fairly good formulation, but really the question here is about, are we orienting our efforts along the correct trajectory here? So is the search for a purely general purpose AI system that's irrespective of its own constraints, irrespective of its own limitations, body, embodiment, and capabilities, are we solving the right problem by making it even more general, or can we actually solve problems by approaching, again, from that converged lens? And the question that I would ask you is, are we currently smart enough to transition all of our energy towards interaction design? Have we already built systems that are intelligent enough? We just haven't leveraged their interaction with the world in order to make them superhuman? Is, I think, a good philosophical question for you.
Yeah. I mean, so I was mostly playing devil's advocate here. I actually mostly agree with your position.
I mean, it's fine. I'm not. Yeah.
But
okay.
Yeah, but I guess like my actual answer to that question is probably that we're not anywhere close to that.
Okay. You don't think so?
We're actually, I think that we're somewhere along the trade-off that you outlined between like to get anything to work for a particular task, that you do need to like put in some effort into figuring out the interface and some effort into figuring out like what sort of problems that you can actually solve. And there's like, probably some trade-off there that's still active.
Okay.
But yeah, I was just mostly wanting to make sure that I could had a clear idea of what the position was first.
Cool, thank you. Yeah, sorry if that felt confrontational to you. I was mostly happy with your formulation.
No, I just was making sure that I wasn't coming across as confrontational.
Okay.
Hey, Abhay.
Hi.
Hey, thank you. I found myself really resonating with just a lot of what you were saying. which I think had a lot to do with considering the context in which we build systems and kind of saying, hey, not only should we consider the context, but we can actually choose the context by doing design. We can actually choose how it is that these systems show up in the world or embodied in the world. We shouldn't just consider some kind of fixed context. And that design question is really interesting to me at the moment, how it is that we do design, what design is, and in particular, what it is about design that we haven't worked out how to automate. I imagine you would agree that we don't know how to automate that design process at the moment.
Right.
Do you have any insight on what it is that allows us to automate some of this intelligence creation that you talked about, but has not led to the real automation of design?
Yeah, that's a great question. So I appreciate the question, and thanks for mentioning that. I'm glad it resonated. I would say in thinking about design, and I want to give like a 10-second teaser to what that means for other folks that might still be confused of like, are we just talking about the hardware design kind of thing? In general, I'm saying that in AI, if we generalize it to the system that a particular single or multiple agents are embodied within, so think of a smart hospital in which you have decision support systems, surgeons, you have predictive systems, you might even have triaging systems and human interfaces. AI is kind of a slice of that entire system in which you are having doctors that are in real time basing their information off of intelligent dashboards and algorithms that are predicting things and failure modes and everything, right? So if you think about developing an AI system as an interaction modality within that overall hospital environment, you can just imagine that there's many different ways to rethink the system beyond can it solve a training test accuracy thing, right? You have to think, okay, well, what are the, what is the interval of precision and recall that I'm looking for, but also more generally beyond that is what is the, what visually am I actually showing and to whom and to when am I showing a heat map or am I showing a classification and how does that then affect downstream applications, right? So that's what I consider the design part of building an AI system, the part that's very contextual, that's driven by the environment in which the system lives. So thinking about why we haven't sort of automated or addressed sort of the generality of how to put AI into a human context, I would say is because there's a lot of fundamental variety, actually. If you think of AI systems, there's a huge variety of what they do and how they function. And in my personal experience, working through Polytopal and working with large companies and small companies, we found that very, very often a company will approach a problem from sort of like a fairly intuitive way that, oh, we want a healthcare system that predicts when someone is going to die so that we can give palliative care early. And instead, we really work to reframe that problem and to show that, well, this system actually needs to be more of a multi-stakeholder decision support system because no one's going to rely exclusively on this AI. Instead, the output of the system should be about argumentation. What are the biggest reasons why you're likely to believe that this person will die? And what are the biggest reasons why they might not? And then a decider like a surgeon or a palliative care expert can go in and quickly triage and understand why the system is giving them that alert. So that's the kind of reframe that I think we haven't yet done. And I think in order to embody a design, an automated system with that, we're probably gonna have to know the landscape of systems that can even sort of be manifested from a given piece of inference. And maybe that's too varied. Maybe there isn't ever gonna be a way where I can just say with complete certainty that it is a multi-stakeholder decision support system with a dashboard in the front office, with a analyst tool that you can query in the back office to find false positives, right? That might never really happen to a meaningful degree.
Yeah, thanks.
Yeah, it's like, it seems like there's sort of like at least a couple different strains of argument that you're trying to make. And one of them seems to be like pushing against like artificiality in terms of a test environment, or I guess in like having a test environment that is purely defined in terms of like a fixed data set with like specific metrics, and that is inherently a like very artificial
Yeah.
environment. Like, is that a fair sort of like good, like,
Yeah,
summary
that's a
of, like,
fair.
part of what you believe? Okay.
Yeah, of course, for sure. This kind of matrix completion idea. Yeah, so go ahead.
Right. And then I guess like more broadly, you were talking about like, it seems like you have like, I'm curious what you think about like narrowness versus generality more broadly. And that I think there's like an obvious argument for, okay, if I'm intentionally building a pretty narrow targeted system, I want to be cognizant of how that system will be implemented. And that just seems like almost like an argument for like interdisciplinarity, right? And that like people natively, if they're like, you know, their background is CS or math, or like, they're like, okay, this is my domain, I don't need to think outside this domain. And this is kind of just an argument for like understanding how your system will be used. But then like more broadly, it seems like it's harder to generalize that in terms of like, it seems like there will be benefits from like not having to like reinvent the wheel on every new system, in terms of like, if there's some kind of like baseline capabilities or, you know, or intelligence that you might want to like implement in like a number of different systems, like it seems like you're going to want some amount of core, somewhat interface independent intelligence, just so you don't have to like use this, like, you know, retrain and recompute things that are shared between systems. So I guess I'm curious, like, what you think the right scope of that is, because I do think that like, that's, you know, people have this belief that, oh, if you create something that's sufficiently general, then you won't have to reinvent the wheel with every new system. That you can sort of use that kernel of general intelligence and kind of like reshape it to whatever the domain happens to be. And I'm curious, like, what your response to like that rationale for like having a more general system is.
Totally. Well, I think it's certainly extremely interesting philosophically and academically to, you know, build extremely large, extremely dense, you know, with billions or trillions of parameters systems that are extremely general and have no specialization at all, and to fill them with data, just rush a massive tidal wave of data at these systems and see where they land, see what the system turns out to do. I think is a great intellectual exercise, you know, a la OpenAI or other organizations around the world that are like Allen Institute, that feel like computation is a limiting factor to the success of artificial intelligence. I personally don't believe in that methodology in sort of the world of creating systems that benefit the world and to people. Inevitably, the case seems to be that there's a level of generality that can afford additional degrees of freedom to what's possible. But for the most part, our systems that work in the real world tend to actually appreciate constraint and limitation and specialization specifically. So it's an interesting philosophical question, right? Like the question of why our brain is very specialized, other than the part that is mostly focused on language, which is basically dense gray matter, but everything else is extremely specialized. So our hippocampus has a very specific pattern of neurons. Our cerebellum has a very specific pattern of neurons that are approaching that. I guess the question is, how general is too general there? And I guess in my mind, I think my advocacy is to sort of pull back on that and to allow folks to recognize that there are these interaction modalities that are really providing tons of value to people with very light kind of general purpose inference that can solve a lot of these problems. But some of the more contrived situations, so for example, you know, a robotic arm flipping a pancake with just a camera, feels a little bit too contrived to really make sense as a real like phenomenon for success, right? You're probably going to want sensors on the fingertips. That seems to be fairly important. If you're going to have dexterous manipulation, it's probably going to be much easier for you to sense, you know, what is at your end effectors than to use, you know, a 1920 by 1080 camera. So I think if you just try to take a little bit of an intuitive glance at information, how information flows in the system, you might realize when your generality is just going in the wrong direction or too general for the problem. And maybe that doesn't feel satisfactory to you, but it's still an ongoing question that I think I have.
So, I guess this lines up with one perspective that's been common in like the algorithmic fairness and the ML bias communities, where basically just trying to reorient the field around application, like very specific applications, rather than like these more general purpose things. And
Exactly,
trying
this
to, like,
non-ideal.
infer back from the context.
Yeah.
Yeah, and then if the field was oriented that way, then the areas for this generality would be more like fairly obvious, in the sense that that because people are trying to like each solve these individual application areas, that when they come up with tools that start to be used in multiple application areas, in the sense that they become the most effective tools, then those tools themselves can spin off into subfields and know that they're being useful because
Yeah.
they're like oriented at each individual application area. And it becomes like, I guess that's sort of most like, or I guess a lot of what I heard out of this talk is pushing towards more that reorientation, where instead of like
Mhm.
trying to do like, I guess instead of trying to factor the problem into intelligence and then after that go like try to like apply that to the real world, and
Yeah.
thinking of the second part as just like this trivial afterthought, thinking of it
100%.
more in terms of like direct application and then having all the other things that you need to do bubble off from that. Is
Yeah,
that
totally. That's a great point, and exactly kind of the thrust of this article that I added on here. The non-ideal perspective is exactly what you're describing. That context-driven, design-driven implementation, which you sort of use kind of a tribal knowledge approach or a context approach in order to solve some of these problems, and you sort of piecemeal and fit in solutions. Now, obviously, to an AI person, that feels extremely like the wrong route, because you want to create this sort of single, elegant system that can automatically sort of address its own limitations and be general and learn the bitter truth, as some people call it, about complexity, overcoming context. But in this case, I would say we don't actually know what is a successful manifestation of such a fair database. I mean, I would probably argue that fairness is something that is extremely driven by humans, and therefore we should probably understand how people react to our systems rather than just think of those systems as solving a data challenge. And so when we understand that reaction and we can form some tribal knowledge around that, we might be able to have a very clear sense of where these systems work. So I'll give you a quick example that's been very relevant to my life. Well, not that relevant, but so if we have a system that is extremely biased, let's say it's extremely biased, it has multiple failure modes, it's socioeconomically judgmental, blah, blah, blah. But we have an interface and dashboard which shows two different models to a judge. One model is a model that includes income or includes socioeconomic factors, and one model that doesn't, right? So we disaggregate, as I call, the system into multiple pieces, and you show a judge two models. What happens? Well, they can't be biased because they can't just, they can't, I guess they could pick one, but then the bias is sort of on the person to say, why do you keep picking this one system? Instead, they actually get to compare the models and form an intuitive human representation of what they're doing. So when I take a look at those and I say, well, the socioeconomic one means he's super guilty, but the non-socioeconomic one shows him as being pretty innocent. That's interesting. Can I use that to inform my ruling and then to inform the system as a whole? Right? So you can develop these kind of systems that are more creatively minded, that still use intelligence, but that intelligence is not end-to-end making the decision and closing the loop. They're providing you a sensible representation of the data, maybe a compressed representation of the data, or a unique representation of the data for humans to interpret and then act and possibly even co-adapt to what those systems are doing.
Have you read much of Mike Jordan's kind of popular opinion pieces on this topic?
I don't think so. I mean, I'm obviously familiar with Michael Jordan, the AI researcher, but I don't know if I've read his thought pieces.
He has a piece that he wrote called Artificial Intelligence: The Revolution Hasn't Happened Yet. And he kind of divides up the space of AI. He calls like traditional AI imitative AI, like people kind of trying to imitate humans. And he says we should think of take a more systems-based approach, and he defines two more terms: intelligence augmentation and intelligent infrastructure. But his kind of thesis is like, it feels to me pretty similar to the type of thing you're arguing, which is we should think of, especially this kind of intelligence infrastructure, like we should just think broadly as AI as just being like one piece of this broader system. And he even goes as far as to say like we need a new discipline, like we need some kind of engineering discipline around intelligence systems. That I imagine, I would recommend if you haven't read. I think I think you would get a lot out of that article.
Totally. Yeah, in a way, that's kind of what I imagine Polytopal is trying to do. Is we're trying to build a repository of successful implementations and works in which we leverage intelligence effectively with interaction, and hopefully we can just learn more and more from that until everybody wants to sort of use some of these learnings for their own thing. So I have a question for you all. I guess from your perspectives around, I don't know how many of you are focused entirely around this notion of sort of provable alignment or provably beneficial AI systems, but how often do you feel like your work is limited by your inability to manifest your algorithm into some system or body, right? Working at a purely conceptual level, how often does it feel like you're limited in your ability to even approach a problem?
I think it happens. I don't usually think of it that way. I sort of often think of it as like, oh my God, this AI system is just not going to, it's going to like spend most of the intelligence of the AI system is going to be like doing super basic things that don't even have to do with the interaction with the human. And so I'm like, all right, half of my work is going to be in making the AI system good enough that it like can understand, that it like graduates to the point where it has to deal with the human as well. But like you could equally well phrase that as an argument that like the interaction modality is, the interaction is like sufficiently bad that most of the AI, like that it's too hard for the AI system to do things that actually involve interacting with the human, and it has to spend all its time learning how to do those things first. And with like better interaction modalities, it wouldn't have that problem.
Yeah.
I think that happens to me reasonably often if I'm working with deep reinforcement learning agents.
Yeah, it almost always happens to me in every instance of deep reinforcement learning that my environment does not transfer at all in any way, and I'm re-engineering the system from the start to put it into a new place.
I guess maybe to that point, like the thing of like re-engineering the system to put it in a new place, I think I'm curious like how you think kind of like modality specific design would fix that, because I think like a basic interpretation of some of the things you're saying would say like, look, you have to train the AI contextually in the context of a specific set of interaction, capabilities, which would sort of feel like it wouldn't tend to generalize across environments. Mm-hmm. But I might be like missing some nuance of like what it means to you to like have maybe a more general interface layer that is maybe like more portable or I'm curious what you think about the like sense in which it seems like you're pushing for things that would be more like environment or like application specific and would have that problem of being like hard to re-engineer between environments.
Right. So I'm not necessarily sort of against re-engineering or to be modality specific. I'm mostly trying to mention how the sort of dream of reinforcement learning is that you would never have to do that, and that the system can automatically sort of approach a new environment with some level of standardized approach and methodology. However, I would say that there are many reusable techniques that we're already aware of. They just are techniques that are what I would call disaggregated. They don't encompass the entire problem domain into a single unified backpropagation, policy finding system. So they're what I would call sort of piecemeal. Those systems are actually really capable and what I would find appropriate. And of course, as we go through time, we sort of find more larger and larger of these general purpose things. So these days, I would say one, really great general purpose tool that is widely pervasive and not nearly as smart as many of us would sort of hope is this notion of like a gradient boosted tree. It's something that in a really simple, straightforward, low compute environment is able to compress some of the relationships between fields in a table into sort of a navigation, almost like telling a data story of a data set rather than leaving them as each row being telling its own story individually. You now can tell a story that goes between these things. Now, it obviously should be limited. It would be very foolish to reconstruct an end-to-end problem where a decision tree is the entire problem. Like I'm not gonna buy stocks based on a decision tree or et cetera. However, fitting it into a small bucket or its own narrow use case, I think is extremely valuable. And that's what I found repeatedly with polytopal, is that when you know how to apply a decision tree very well and you narrow it, so you remove fields that it might not make sense for it to know about, and you remove degrees of freedom for that system, you end up with like something that can be extremely useful. And the same cannot be said about these highly entangled, end-to-end AI models in which you're adding all sorts of additional losses to kind of compensate for odd forms of context. So I think like a general purpose CNN is actually fairly good, but if you keep it compressed into its own problem-solving space and don't extend it to encompass an entire end-to-end problem, it's better. That's what I found. So we will find these kind of unitized techniques, and I think a CNN and a decision tree are both in that space, and I would advocate against expanding them to do things they probably weren't designed for.
Yeah, I guess one answer, so to Cody's original question, like when I said that some of my things could be improved by modality, by changing the interaction, I didn't really mean that you could train it using a specific interaction that would generalize to other environments. I more just meant like, to take an example you'll be very familiar with, like deep reinforcement learning from human preferences. Usually, like on a complex enough environment, it just takes forever and is real hard. But like if you instead if you instead designed like a hierarchy of actions where each action does some sort of sensible thing with maybe a couple of parameters that you had to fill in, I would expect it to actually work.
Exactly. Yeah, and exactly. I think that's the exact kind of design mentality that I try to bring to a lot of these situations is, can I actually reduce, the theta as much as possible to still be useful to some of the core things that I don't know or don't want to know or can't know, I guess, about the system a priori. But if I'm doing deep reinforcement learning for human preferences, I don't necessarily want to train a system that's generalizable to, teaching a person to ride a bike, but is also generalizable to helping you cook, right? The system's going to end up having to spend all of its time learning how to move your arm to the spatula and putting its feet on the pedals, when in fact, like, if we can narrow it to maybe some small degrees of freedom and just let a stupider system that knows how to cook and ride a bike, maybe we might actually be able to approach that problem to a meaningful degree.
So it
Cool.
is 4:25. We have like about 5 more minutes until the end of the seminar. So any like last threads that people want to talk about, questions you've been saving till the very end?
I guess just a more general question is like, I feel like a lot of what you said makes a lot of sense in the context of like having specific applications, but like there's also obviously like ways in which a lot of people here or a lot of people in research are like inherently doing things that are a bit more general. They aren't rooted in a company. They maybe don't even have access to like, either they aren't interested in it or they like, don't necessarily have access to like a user base who they're like optimizing for or something. And I guess I'm curious, like what you think the role of research is in your kind of worldview, which is like, I think inherently a bit more abstracted from a like particular like mode of interacting with the world, as opposed to like, data science at a company or something, which I think fits a lot more cleanly like into the model that you've built.
Yeah, totally. It's a great question. I personally am fairly against this notion of academic research where you sort of have both a core research problem, but then you also spend a lot of time, applying for funding, giving sort of semi-fake applications of that research that most likely would require an entirely separate research grant for that application itself. So I'm actually a big fan of investing in core research for the sake of it and thinking about sort of general problems that don't necessarily apply and don't have to have a physical manifestation in order to be successful. And then as a physical manifestation, you sort of admit that you're probably not going to need to do as much of that core research, but you're really going to be doing a lot more of the applied engineering where you're taking a lot of off-the-shelf tools and you're remixing them to fit the problem domain. But someone needs to make the tools on the shelf, and then someone needs to take the tools on the shelf and make things that exist in the physical world with them. And so to me, I feel like those should be two separate concerns, but we kind of live in a world where as AI researchers, people expect us to go directly from, local Jupyter notebook to customer deployment where we're, solving credit claims or something, some important domain that's probably going to require way more context dependence and tribal knowledge. So that would be my only thought around, generality being clearly important. And there's no reason that, we're living off the backs of a lot of AI research, but I think that there are probably a lot of, there's a graveyard littered with people taking theoretical approaches to practical problems.
Cool. I think I'm going to declare the official end of the seminar. So let's thank our speaker again, which I'm just going to do on behalf of everyone. Ooh.
Thank you.
Amazing. This is a Zoom room. We do not have to actually leave it, so people should feel free to stick around and continue to chat. But this is the shelling time